Welcome to our fourth lesson on integration. In our previous lesson, we learned about definite integrals, and we said the integrals of the form, the integral sign a to b y dx, which basically means integrate y with respect to x and evaluate the resulting integral for the limits x is equals to a and x is equals to b, where x is equals to a is the lower limit and x is equals to b is the upper limit. In our lesson today, we'll be learning about indefinite integrals. And just to quickly remind you what we had covered in the previous lesson, the integral sign, as indicated over here, is an instruction to integrate. And if you are provided with the integral sign, y dx, it means integrate the expression for y with respect to x. And if you have, for example, in a question, the integral 2x plus 1, dx, it means you integrate what is in the bracket with respect to x, and that will be able to give us the result 2x squared over 2 plus x plus the arbitrarily constant c, which again from our previous discussions we were able to learn that if you're provided additional information, you can be able to determine the value of the arbitrarily constant c. Notice in the expression, this one over here, this symbol is called the integration symbol. 2x plus 1 is called the integrand, and dx is referred to as the differential. Now, an indefinite integral refers to an integral in which the limits of integration are not specified, or is an integral in which the limits of integration are open. Examples of indefinite integrals include the integral 2x plus 1 dx, the integral 3x cubed plus a half x squared minus x plus 1 dx, the integral dx, the integral 2t plus 3 dt. Now, interestingly, in all these four integrals, the limits of integration have not been specified, and hence they are referred to as indefinite integrals. Let's take our example number 1. Work out a, the integral 9x squared plus 2x plus 1 dx, b, the integral 3x cubed plus a half x squared minus x plus 1 dx, c, the integral dx, and d, the integral 2t plus 3 dt. Since the integral symbol is an instruction to integrate, we will integrate for all of the four provided questions, whatever we have in brackets, with respect to x. And for the first question, we are going to integrate 9x squared plus 2x plus 1 with respect to x, and that will give us 9x cubed over 3 plus 2x squared over 2 plus x plus the arbitrarily constant c, which when we simplify will give us 3x cubed plus a half plus x plus the arbitrarily constant c. Similarly, for the second one, we're going to integrate 3x cubed plus a half x squared minus x plus 1 with respect to x, and that will give us 3x to the power 4 over 4 plus a half x cubed over 3 minus x squared over 2 plus x plus the arbitrarily constant c, which will also simplify to give us 3 over 4 x to the power 4 plus 1 over 6 x cubed minus a half x squared plus x plus the arbitrarily constant c. For the third one, we are required to integrate the x, and that will give us x plus c, because we can be able to look at this particular question in the manner of the integral 1 dx. And when we are integrating a constant, we're basically introducing the variable and then we're adding arbitrarily constant, and therefore this will be able to give us x plus the arbitrarily constant c, and therefore the integral of dx will be equal to x plus the arbitrarily constant c. And lastly, for the fourth one, we are to integrate 2t plus 3 with respect to t. That will be able to give us 2t squared over 2 plus 3t plus the arbitrarily constant c, which will be able to simplify to t squared plus 3t plus the arbitrarily constant c, because the 2 on the upper side is going to cancel with the 2 on the lower side, so that you're only remaining with t squared, and then we add the 3t, and then we add the arbitrarily constant c. In example number 2, it will be done the same way as example number 1, and therefore we will need to integrate what we have in the bracket with respect to dx or any other variable that is provided, and add our arbitrarily constant c. For the first one, which is x squared plus 1 integrated with respect to x, we are getting x cubed over 3 plus x plus the arbitrarily constant c. And for the second one, which is integrating x cubed plus 4x with respect to x, we are going to have x to the power 4 over 4 plus 4x squared over 2 plus the arbitrarily constant c, which will simplify to x to the power 4 over 4 plus 2x squared plus the arbitrarily constant c. And lastly, for the third one, we'll be integrating x plus 1 with respect to x, and that will give us x squared over 2 plus x plus arbitrarily constant c. Note, as discussed in previous lessons, if additional information is provided, the value of the arbitrarily constant can be determined for indefinite integrals. Practice what you've learned in this lesson by pausing the video and trying these questions. In summary, in this lesson, we've learned that an indefinite integral is an integral in which the limits of integration are not specified, or is an integral in which the limits of integration are open. It can be represented in the general form of the integral y dx, in which the integral sign is an instruction to integrate, and then the y is referred to as the integrand. The dx is referred to as the differential. We further notice that once you've integrated and obtained your integral, the value of the arbitrarily constant c can be determined if some additional information has been provided. That's all for now. See you in our next lesson.